This is a single server setup. In such a setup, all the components of a web application, such as the web app itself, the database, and the cache, are running on a single server. Here is the server as the central node that handles requests from both web browsers and mobile apps, and the domain name system's role is translating domain names into IP addresses so that user requests can reach the correct server. So here we have a single server setup. It is a great starting point for building a system, especially for a small scalar project or prototypes. It is simple to set up and manage, so it can be quite cost-effective. So in a single server setup, all of the components of your application run on the same machine. This includes the web browser, which handles incoming requests from user, and the database, which stores your application's data, and the cache, which speeds up the data retrieval, or any other necessary component, such as a message queue or search engine, blah, blah, blah. The first thing is user input. The process begins with the user initializing a request. So this could be through a web browser or a mobile app or any other client that interacts with the server. And then the user enters a domain name or a URL. Since remembering IP addresses for all of the website would be impractical, the domain name system translates these domain names into IP addresses. So DNS is essential for us to navigate the internet because it is much easier for humans to remember those domain names than long strings of numbers. The domain name serves as a human-readable address for all of the websites, so users just need to enter a domain name in their web browser or mobile app. So these client devices will contact the DNS servers, typically provided by the internet service provider, because the client device doesn't inherently know which IP address associated with which domain name, so it needs to consult a domain name system server, and the DNS server just looks up the IP addresses which associated with which domain name in its record. So the DNS server acts as a directory which translating user-friendly domain names into machine-readable IP addresses so that computers can understand. Then it just returns the IP addresses to the client's devices. Equipped with the correct IP address, client device now sends a direct HTTP request to the web server, which located a NAT address. So these requests contain specific information about the desired resources, such as a specific web page or API endpoint. The process is, first, the client device constructs a hypertext transfer protocol request. The user's device then sends this HTTP request to the web server at the provided IP address. HTTP is a protocol used for transferring web pages on the internet. When you visit a website, your browser sends an HTTP request to the server, which tells the server what it needs to do to complete the request. So the HTTP request includes the request method, such as GET, POST, etc., and the path to the desired resources, and additional headers like user agent, like cookies, something like that. So this request is directly sent to the web server's IP address by just using HTTP protocol. The web server receives the request and parses it, so it processes the incoming HTTP request and sends back the appropriate response. So this typically involves several steps. So first, it tries to locate the requested resources. The server identifies the specific file or data that the user is requesting, which locates the requested resource, like a specific web page file or API endpoint. If the request involves accessing a database, the server fetches necessary information. It retrieves data from a database or any other data sources. The server constructs an appropriate response. This response could be an HTML page, which is a standard markup language for creating web pages so that the web browser can display, or a JSON object for a mobile app to consume, which is JavaScript object notation response, which is often used by web services to send structured data. that can be easily parsed and used by web application. And the third kind of response is the image or any other media file or any other type of data. The final step is response to client. Once this response is ready, the web server sends generated response back to the client device. So this response includes the response status code like 200 OK, 44 not found, or the response heads, or the response body, which contains the HTML, JSON, or any other data. So the client receives this response and renders it appropriately, like displaying a web page in a browser, presenting data in a mobile app. One of the biggest advantages of a single server setup is its simplicity. It is easy to get up and running, so it is relatively easy to manage and maintain, and there's no need to worry about setting up or configuring multiple machines or dealing with complexities of distributed systems. Another advantage of a single server setup is its cost effectiveness. You only need one machine, so you will save money on hardware, software, and network costs, and this can be a major advantage for small businesses or startups with limited budgets. However, there are also some disadvantages to a single server setup. One of the biggest drawbacks is that it can be a bottleneck. If your application starts to get a lot of traffic, the single server may be not able to handle the load, or this can lead to slow performance or even outages. Another disadvantage of a single server setup is that it is not very fault tolerant. If the server goes down, your entire application will go down with it, and there's no redundancy, so you will need to take steps to back up all of your data and make sure you have a disaster recovery plan in place. This kind of architecture is typically used for simplicity and is common in early stage of development or for small-scale applications where the ease of setup and maintenance is priority over scalability and fault tolerance. But as the traffic grows, the system might be evolved into more complex architectures, such as microservices, where different components are spread across multiple servers or services.